Okay, I already started to draw in advance, so I could stay more just discussing the problems, because it is too much information. Okay, the video would be huge, so I just try to make everything written except this part. Okay, that shortly I'm going to write for you. Okay, let's start. This is our equation, and before that I would just like to tell you that we have many things we have to consider in here. The first one is a signal, second, amplitude, third, the period, fourth, the signal, direction, and fifth, the magnitude of the phase shift. It's a lot of information that you have to carry to this chart. It's very easy as long as you just know what you're doing. And this video, the intention it is to make you never miss again a chart like this. Doesn't matter if it's sine or cosine, okay? It doesn't matter. They are both the same, okay? But the cosine is going to start like this, and this sine is going to start right at the zero, okay? In here, at the origin. Basically, they are the same. Okay, now, the first information I have to acknowledge, it is this one, okay? It's negative in here. What does it mean, a negative in here? It means that we are going to flip over the chart, okay? Flip over the chart on the y direction, okay? Just flip over. When we have a crest, that crest is going to become a trough. That trough is going to become a crest. That crest is going to become a trough, okay? Just changing the signal here does not alter the roots. The roots is when the curve meets the x-axis, okay? So the roots are not changed, only the troughs and the crest, okay? Just like flip over. Now, next one, the amplitude. The amplitude, it is just stretching the chart on the y direction, okay? Only that, just like we did here, the red curve, okay? Stretch it up. In our case, it's 1.5. Then we have this number, the period. And we have to be careful about, because the period is going to exert an influence over the phase shift, okay? We have to read the phase shift and then apply something above that, which is going to be the period change. So if we have a multiplication here, means that the period it is going to be divided by 6, okay? It is inverse. If this is multiplied, the actual period it is going to be reduced. Just like that, okay? When we reduce the period, we just shrink the chart, okay? In here, we are going to shrink it, and we are going to have more crests and troughs, okay? Because we're just shrinking the chart. It is the shrinking thing. It is the red curve. Now let's discuss about the phase shift. This is just the direction. A plus in here means to the left in here, and a negative signal, it means a shift to the right, okay? A positive one, it is the reverse, okay? In our case, okay, look in here, I try to draw the curves in here, okay? In blue, we have our original cosine of x, okay? This is cosine of x. I don't know if you can read in here, is cosine. And what we have in red in here, because we have a plus in here, we are going to take that curve and make it to the left. So every single point, it is going to be moved to the left. You see, that point was taken to the left, that point, that trough went to the left, everything to the left. If we have a plus in here, which is our case, the opposite takes everything to the right, okay? Now, this is the direction of the phase shift. Now let's see the magnitude. Because the cosine has a period of 2 pi, meaning every 2 pi we start over again, or every 2 pi, this is 2 pi, okay? Every 2 pi, we just have a crest to crest. We have another cycle, okay? This cycle, they last exactly one cycle. For the cosine is 2 pi, one period. Again, this is again, let me just put in here. This is again from trough to trough. We also have a period of 2 pi. Again in here, this is also 2 pi, okay? Now, because we have a period of 2 pi, every 2 pi, you see, take this 0, add 2 pi, we are still on a crest. Add more 2 pi, another crest, 2 pi, another crest. Take that point in here, okay? If we just add 2 pi, we are going to land in here, okay? Not in here, okay? Why? Because this period, I mean, this point is when we are starting to go up. It can't be this one. We are going down here. It can't be, okay? The period, the end of the period is when everything starts over again. So that point, we are starting to go up, is going to be this one, okay? So from that point, it is again going to be 2 pi. This means a period. And because every 2 pi, everything happens the same, if this is a multiple of 2 pi, it is going to mean nothing about charting, because it is not going to affect our chart, because that point, it is going to be exactly in here, okay? So we just have to account for something that it is not a multiple of 2 pi. That's why I wrote in here 21 pi equals, okay, a multiple of 2 pi, in this case a 10, plus pi. We don't have to worry about this multiple of 2 pi because this term is not going to affect the period, okay? It's not going to affect the charting, okay, on the charting itself. Why? Because everything is going to land in the same place. It's just like I do this. This is my hand. If I just do this, okay, you can see the hand behind, okay? But if I do this, this is a phase shift different than 2 pi. And this is a phase shift of exactly 2 pi, okay? We just can't see what is underneath because it is exactly at the same position, okay? So every 2 pi you don't have to worry about, only when it is different. For instance, if we have 700 pi, we would not have to consider about phase shift because it's a multiple of 2 pi. But if we have 727, then we would have to consider. 726, we would not have to consider because it is a multiple of 2 pi. Okay, but in this case, we have to worry about this lonely pi in here, okay? The 21st. This first is one that's going to change the shifts. So, something also important here. When we are discussing about phase shifts, we have to understand that we are doing two things in here. One thing, it is making a phase shift to the left because it's a positive, okay? Positive phase shift to the left. So we are taking our chart to the left, meaning we are going to bring that crest to the left. Yes, we are. We are bringing that trough to the left. Yes, we are. But we are not just doing that. We are taking our chart to the left, and at the same time, we are doing this. So it's very weird because it is two movements in the same one, okay? And so one isolated pattern would be like this, a phase shift to the left. It's very easy to understand this. Another concept, it is this, when we are making a shrinking, okay, on the x direction. This is making a shrinking. And notice this, and please pay attention to this. This is the most important part on this entire video. When we're making a phase shift, both points, every single point is moving along and together at the same speeds. We are just making a translation. Remember, from physics, a translation means we're just moving the body entirely without rotating, without expanding, contracting. We're just making copy-paste. Just take that thing in here and translate in here, okay? We can even do this or do that. A translation means no movement except every single point transferred to this point at the exactly manner without rotating and even changing the speed and anything else. Every single point must be transferred to that point at the exactly same way. So this is a translation. This is a phase shift. This is something. Now, when we apply a number in here, in this case, we are making a reduction. Look what's happening. It is totally different. The right side, it is going to the left, but the left side, it is going to the right. They are going into different directions, okay? And this is going to make a mess in this chart, because look, we are making a phase shift, okay? So supposedly both points, okay, let's suppose we have a crest in here and a crest in here. If we just make a phase shift, both crests are going to the left. But when we make a phase shift with a change on the period, look what's going on. Pay attention to this hand first, only to this hand. Okay? It went to the left. Now, pay attention to that hand alone. I'm making two movements, phase shift, and I'm also shrinking. Okay, I'm going to try to do my best. You see? This one hardly moved, or even might even have moved ahead. But to say, how can we make a phase shift to the left and that crest is moving forward? Well, depends. If we are shrinking faster than we are going to the left, that point is going forward. So can you see the mass it's going up in here? So that is why we cannot take a point in here and transfer to that chart in here. It's impossible, okay? Not impossible. Depending on the way, you can manage to do this correctly, okay? Sometimes I do this straight, but it's not the best way to teach, okay? The best way to teach you is this. Don't try to take that point and move to that chart in here. Chances are you might get it wrong, okay? This is not the base to solve, okay? And what is the best way? And now, okay, the chart is going to start at 12 minutes and 20 seconds, okay? This is where the charting starts. What is the best way I can teach you to draw this? We have to look at the equation. I believe this is the safest way. It is not the only way, okay? I don't believe that we have just one way. In math, we have several ways, okay? But my idea here for you is, let's just look at the equation. It's impossible to miss if you just look at the equation. So our starting point, okay, it's going to be x equals 0, okay? So let me see if I can do in here. I'm going to write down here because I don't want to waste too much space. So our starting point, this is the most important part, okay? Our start point is going to be x equals 0. If we just apply x equals 0 in here, look, I'm not going to write too many things in here because I don't have space. I'm going to do it verbally. When x equals 0, we're going to have a cosine of 21 pi. We have seen that 21 pi, it is the same as pi, okay? So y, it is going to be minus 1.5 times the cosine of pi, okay? Because 21 pi and pi, it is the same for the cosine. Okay, and what is the cosine of pi? It is just minus 1, isn't it? So our y is going to be plus 1.5, okay? So our starting points, it is going to be this point, 0 and 1.5, okay? We also know that, okay, so it is going to be 0, 1.5, okay? And let's suppose 1.5, it is right in here. This is our 1.5. So now let's draw the limits. This is plus 1.5. Oh, it didn't. Okay. This is going to be 1.5, and this is going to be the negative 1.5. Okay? So this is going to be 1.5, and this is going to be negative 1.5. The first part, it is done, the amplitude. Okay? And we have our starting points. Let me draw in here. This is going to be our starting point. And this point we know. This is the most important part, because if we start wrong making the charts, everything's lost, okay? Just be careful about this. And let me tell you secrets. Once we fix that point, the exercise is delivered, okay? We don't have to worry about almost anything else. Well, let me show you a trick now. Once we have your starting point, okay, and this is going to be a crest, right? The same crest as this one. Now, remember something. What does it mean to go from crest to crest? It means to go one period, right? So our next crest, it is going to be the period, okay? But now look what is going on here. What is going on with the x direction? Everything is being shrunk by a factor of 6, isn't it? It means that if our initial period was 2 pi, that means that our period in here, and let's write it here, so our period for that function, our period in here, it is going to be 2 pi divided by 6. Okay? Why? Because everything on this chart is going to be reduced by 6 on the x direction. The period, it is discriminated as being on the x direction, okay? It is in this axis. Therefore, the period, it is going to be affected by this guy in here. And so the new period, it is going to be just pi over 3. That's it. That's all we needed to know about this exercise. Okay? Now, let's draw our trough in... Okay, let's draw in green. Okay? Let's make like this. Let's draw like this. Our troughs are going to be with a circle, a red circle. From crest to crest, it is a period. The period is 2 pi in here. Therefore, the period in here is going to be 2 pi divided by 6. Everything, it is shrunk by 6. Okay? Now it is going to be pi over 3. That means that from that point to that point, okay, I'm going to add a pi over 3. And that's going to be my next crest. Again, if we just add more pi over 3, I'm going to get the next crest. Again, if I add again plus pi over 3, I'm going to get my next crest, and so on. Okay, next, always plus pi over 3. Okay, plus pi over 3. And 1, 2, 3, 4, 5. Yeah, I believe I have one more. Okay. Okay. Again, I'm not going to say to write it's going to be a mess, but this is another crest. Okay. I know this point. This point is correct. Why? Let's review a little bit. I took this point because I used the equation. I know that this point is true. Okay. So that point I know. If we know this point, and we know that from crest to crest it is a period, and you know that the period, it is going to be pi over 3, okay, you just take that period divided by 6, then you know all the crests, and all those are all going to be crests. Very simple, okay? Now, okay, once we know all the crests, now let's draw the troughs. I know that between 2 crests we have a trough, right? Okay. If the crest is in here and in here, the trough in here is going to be the middle point. Okay? So I'm just going down right into the middle and in here. This is going to be a trough. Okay? Now, I can go over and over like this, always taking the half parts, or just understanding then that from trough to trough, I have another period. But the period, it is pi over 3, isn't it? So I just have to start the same process over and over again. If I just add pi over 3, I'm going to get all the troughs. Okay? Always plus pi over 3 plus pi over 3 plus pi over 3 plus pi over 3. All those are going to be troughs. Now, once you know that this is a crest, this is a trough, I'm going to make in pencil and then I'm going to make in pen, right? Okay, and I have these points in here, right? Then I'm going to erase so you can just see what I'm doing, okay? You see this line in here? So, well, this is the middle. So I'm going to go like this. It goes like that. And then go up again. And it goes like this, okay? I'm going to try to make, I don't know which pen I'm going to, yeah, I'll try to use this pen in here. So it's going to be something like this. Like this. And then go up. It's very difficult because, okay, again, I have to land over here again. The middle point is this, so it's going to pass around this portion here. This is going to be like this, right? It's going to be something like this. Okay, again. Okay, and again, and again, and again. Okay, and this point I have to connect with this one. Okay, and again, and again, and again, okay? And then just have to be patient. To draw everything. Okay, and then we do on the other side. Okay, and here, and so on. Okay, I'm not going to do all the way. Okay, there is no point doing all the way. Just got the idea, okay? And just something that I would like to remind you. What is going to be this last one? Let's put the numbers in here. This is going to be pi over 3, okay? Pi over 3. This is going to be 2 pi over 3. This is going to be just pi. Then 4 pi over 3. This one is going to be 5 pi over 3. And this is going to be our 2 pi. I just wanted, before I close the video, I would like just to show something. From 0 to 2 pi, we have one cycle, right? One period. Now, let's see from 0 to 2 pi in here. We have 1, 2, 3, 4, 5, 6. It's an agreement, okay? We have one interval over 0 to 2 pi, which is one period. And here we're going to have 1, 2, 3, 4, 5, 6. We're going to have 6 cycles, okay, over the same length. Why? Because we have shrunk 6 times like this, okay? I just didn't discuss too much about the phase shift because I don't use the phase shifts. I prefer to understand this. I prefer to say where it is the first point, the starting point, okay? So let's just put in here, the start point comes from here, okay? That's how I got my starting point, 0 and 1.5. So to plot, what do? You just figure out what is going to be your starting point. For me, I just choose x equals 0. Make x equals 0 and see what is y. Once you know our starting point, okay, once we know our starting point, which is this one, okay, this is our starting point. Once we know that starting point, then all we need is to say what is going to be your new period. Our new period is going to be pi over 3 because it is the original period divided by 6. Then just start adding, okay, crasses, okay, and we know that between two crests we have a trough, and between troughs we also have the same period, okay? But I would just like to discuss something here. In case that it is being asked the phase shift, this phase shift, it is this shift in here, okay? Take account with the signal. If it is a plus, the phase shift is going to be negative, and if it is in the case of sine and cosine, if it's an even number in here, okay, an even number in here along with pi, the phase shift is going to be 0 because it's a multiple of pi. But in the case we have anything that it's not an even number in here, then we're going to have a phase shift. So in this case, the phase shift is going to be minus pi, but you have to take into account this. Don't forget to acknowledge, okay, that number, it is going to affect the phase shift. Why? Because the phase shift, it is also going to be reduced. Why? Because this phase shift, it is located at the x direction. Everything that is inserted on the x direction, it is going to be affected by the phase shift, okay? And that's it. I'm going to make a new video. It's going to be exactly based on this paper, but it's going to be very fast, okay? So if you want to review, just take our my next video, and see you in a few seconds.